drawing. Here we push it from this side. HO tube drawing, HO H1 sigma 2 we apply here, mu1 mu2 mu1 mu2. There will be mandrel here, types of mandrel plug. This is called mandrel, so that internal diameter will be kept at this distance. Cylindrical, it will be like this: 2 gamma is equal to 0, gamma is equal to 0, 2 gamma is equal to full cone angle. Conical mandrel preferred, it will be like this: 2 gamma not equal to 0, gamma not equal to 0, it will be like this. Drawing stress, sigma 2 is equal to sigma y into 1 plus beta by beta into 1 minus h1 by h naught whole power beta, where beta is equal to mu1 plus or minus mu2 by tan alpha minus tan gamma. Mu1 is equal to friction between outside surface of tube and die. Mu2 is equal to friction between inside surface of tube and plug mandrel. Stationary plug, beta is equal to mu1 plus mu2 by tan alpha minus tan gamma. Reducing wall thickness of an already existing tube with or without the change of internal diameter and with or without the use of plug or mandrel is called tube drawing process. Tube sinking, when there is no support given to the tube from internal side, that is when the tube drawing is done without any plug or mandrel, is called tube sinking. There are two types of mandrels used. Cylindrical mandrel, generally it is used to maintain the same inside diameter of tube, 2 gamma is equal to 0. Conical mandrel, it is having some conical angle, that is 2 gamma not equal to 0. It is generally used to change internal diameter. Mandrels are generally used in three conditions. Stationary mandrel, stationary plug. When plug is kept stationary at inside surface of tube and supported from outside source, it is called stationary mandrel. In this case, friction mu2 is acting in same direction as that of mu1. Beta is equal to mu1 plus mu2 by tan alpha minus tan gamma. Gamma cone angle. Floating mandrel, in this case the mandrel is left over inside the tube, and because of friction it continuously floats inside the tube. It is called as floating mandrel. In this case, friction mu2 acts in same direction as that of mu1. Beta is equal to mu1 plus mu2 by tan alpha minus tan gamma. Movable mandrel, when mandrel is moving inside the tube, the friction is acting in opposite mu2 is acting in opposite direction of mu1, that is friction of the tube is forward direction. Beta is equal to mu1 minus mu2 by tan alpha minus tan gamma. Generally only cylindrical mandrels are used. Gamma is equal to 0, tan gamma is equal to 0. Case 2 ideal drawing, mu is equal to 0, mu1 is equal to mu2 is equal to 0, sigma 2 is equal to sigma y ln ho by h1. Movable, case 3 movable, if mu1 is equal to mu2, beta is equal to mu1 minus mu2 by tan alpha minus tan gamma is equal to 0, sigma 2 is equal to sigma y ln ho by h1. Extrusion, force is applied like this. This is ram, pressure plate, container, die. This is die. Forward or direct extrusion. If we apply force here, we will extract here. K is equal to AO by A1 is equal to draft. The percentage reduction in area is equal to AO minus A1 by AO into 100%. 2 alpha is equal to full die angle. AC is equal to circle. These are different cross sections. AO VO is equal to A1 V1. Volume, here VO V1 are velocities. AO by A1 is equal to V1 by VO. V1 greater than VO. In extrusion process, compressive force is applied on billet material from backside by movement of pressure plate. Therefore, billet material starts experiencing the compressive force from all direction, that is hydrostatic compression. At one point, the compressive stress keeps on increasing and becomes exactly equal to flow stress of material. Therefore, at that point, entire solid materials gets converted into gel-like structure, and therefore, material starts flowing, and by taking a shape of opening provided in die, components get extruded. Complex cross-section components can be produced easily. Any cross-section reduction in is possible in one stroke. At one stroke, that is, only one stage is required for extrusion. Because of compressive force, deformation takes place is always 100% permanent plastic deformation. Value of stress does not go beyond flow stress. Chances of fracture is negligible. Comparing the discharge before and after extrusion, AO VO is equal to A1 V1, V1 greater than VO. Velocity of an extruded component is greater than velocity of ram or pressure plate. Sometimes AO by V1 is equal to VO by V1 is equal to 40 to 50. Types of extrusion: forward extrusion or direct extrusion, backward or indirect extrusion, hydrostatic extrusion, impact extrusion. Forward or direct extrusion: when extruded components are moving in a same direction as that of movement of ram or billet, it is called as forward or direct extrusion. Inner wall friction is present, therefore amount of force and energy required is also very high. When brittle and semi-brittle materials are extruded, uh, surface cross surface cracks are observed, and therefore brittle materials are never allowed to extrude by forward or direct extrusion. The handling of component is relatively easy. Shear force sigma f ram travel. Ram travel increases, stress increases still here and then decreases. Forward extrusion, it will keep on decreasing. Forward or direct. Backward or indirect extrusion. Ram ram is placed here. Closure plate. Extruded component. Here this container. When extruded component is moving in is called backward or indirect extrusion. Here, die is performing an additional function of pressure plate. Billet material remains in a standstill condition, whereas die is moving towards billet for extrusion to take place. Friction is zero. Container wall friction. The force and energy required is less, like this. The liquid performs two functions. It eliminates the contact of billet with container. It acts as a medium to transfer. Friction is zero. Force and energy required is less than forward extrusion. Brittle and semi-brittle materials can be easily extruded. This is the best process of extrusion. It is one of the type of forward extrusion. Impact extrusion, hollow backward extrusion. Punch die billet or ductile material is placed here. It is dropped, then it will move like this. You will get U-shaped. Or in this process, impact load is applied on a billet of extremely ductile material. Therefore, it is called as impact extrusion. Billet material flows in opposite direction as that of movement of punch, and therefore it is called hollow backward extrusion. Hollow back external not given, k is equal to extrusion constant not given, eta given, then external load is equal to sigma y into AO, final extrusion load is equal to sigma y into AO by eta. And extruding at low temperature loads to generate a lot of surface cracks. It is called bamboo defect. Fishtail pinhole or pipe defect when air gets stretched and called hydrostatic tension, which may be leads to fracture at center of extruded component called as center burst. Extrusion process can effectively reduce cost of product through material saving. Toothpaste is produced through hollow backward extrusion. Forging top die movable, bottom die stationary, initial DO, final DF, HO initial, HF final. Volume before is equal to volume after pi by 4 DO square into HO is equal to pi by 4 DF square HF. DF is equal to DO root HO by HF. HF is equal to HO DO by DF square. Forging is a process in which given raw material is compressed with the help of die to get final finished part by plastic deformation. Forging can be done in a hot or cold working operation. Material is always considered as incompressible, that is volumetric changes beyond zero. Classification of forging operation based on type of force applied, based on source of force taken. Hand forging, whatever the force required for deformation, if it is taken from human hand, it is called hand or man forging. Machine forging, whatever the force required for deformation, it is taken from a machine, it is called machine forging. Based on nature of force applied, press forging, when a gradual increasing load is applied for plastic deformation of raw material, it is called press forging operation. Drop forging, when a sudden impact load is applied for plastic deformation of raw material, it is called drop hammer forging. Hammer HO HF DO DF. Work done is equal to E is equal to F average into HO minus HF. 2 into mg capital H is equal to capital H is equal to F average into HO minus HF. HO minus HF. Work done. This is hammer M G capital H. Potential energy is equal to P is equal to mgh is equal to weight into H. Sigma square by 2 E into LA is equal to P into delta L. Sigma square by 2 E into LA is equal to sigma L into P by E. Delta L is equal to PL by AE. Sigma is equal to sigma L by E. Sigma is equal to 2 P by A. Impact load for gradual load. Sigma is equal to P by A. or sigma is equal to E epsilon, sigma is equal to E delta L by L, delta L is equal to sigma L by E. Mechanism of forging: expansion force, frictional force, barkling, sticking, two sliding. When force is applied by downward movement of top die, the height of body reduces, and to compensate reduction in height, outward expansion force is generated to increase the diameter of material. Initially, the material tries to expand will be resisted by generating the friction by stationary die by stationary die surface, but only at time of raw and only at the end of raw material, whereas away from end there is no frictional resistance. Therefore, material simply expand and produces barrel shape component. As material simply stick to die surface, it is called as sticking friction model. On continuous downward movement of top die, expansion force keeps on increasing, and at one point expansion force ideal not mentioned. Fi is equal to sigma y into A1, Ff is equal to sigma y into AF. F average is equal to F1 plus Ff by 2. F max is equal to F average by eta. Case 2 mu is equal to given F max is equal to sigma y into AF into 1. Open is called open die forging operation. It is basically used for reducing the height of component. Closed die forging operation, impression die forging. Here top half of the cavity is created in top die, whereas bottom half of cavity is created in bottom die. When both top and bottom die gets closed completely, the final finished component gets manufactured. It is called as the closed die forging operation. Here volume of raw material selected is 10 to 20% extra than volume of final finished component. This the extra volume provided is collected at a place called a gutter. Because gutter extensions gets reduced on a forged component called as flash. Flash is wastage which can be cut by after forging by trimming process. Final cross section, gutter. This is flash. Gutter, parting line, cavity, thin finish line, thin flash line. In closed die forging operation, extremely thin flash land is provided between gutter and main cavity. Therefore, during actual forging operation, a lot of pressure is required for moving the material through thin flash and can flash land, and therefore slowly the pressure in cavity starts increasing, which allows the material to fill entire complex intricate shape of the cavity. The material in flashland is also wastage which is cut by trimming operation. The material in gutter and in flashland provides an extra cushioning effect to the material in forging cavity. The vertical walls of forging die are made into an inclined surface for easy removal of component from die called as draft angle. Preliminary or preparatory forging operations, fullering, distributing the material from center towards edge uniformly is called fullering operation. Drawing, distributing the material from center towards edge uniformly is called drawing. Offsetting, reducing the height and increasing the diameter is called offsetting operation. Fullering, it is made like this, just drawing, it is made like upsetting, this offsetting, reducing height, increasing. Edging, collecting material locally at required place is called edging operation. It is an open die process. Flattering, producing a flat shape of component in an open die forging operation is called flattening process. This is called chamfering. This is called flattening. Chamfering, removing the sharp corners and producing fillet corner welds in an open die forging is called chamfering. Bending of your raw material in required direction by required angle is called bending operation. Blocking or swagging, producing a nearness to final shape of component in closed die forging is called blocking or swagging. Finishing, producing exact final shape of component in a closed die forging operation is called finishing operation. Trimming, cutting the material along entire circumference is called trimming operation. Blocking, finishing, and trimming are compulsory operations. Operation 1 to 7 are open die forging, whereas 8 and 9 are a closed die forging. This blocking or swagging and finishing closed die forging. Operations 1 to 7, that is initially forging operations in hot working condition, whereas cast open, that is blocking and blocking, swagging, and finishing are preferred in cold working. The advantage of forging operation: improved physical properties. Grain orientation is possible. Forging method for reducing diameter of bar and in making it longer is termed as fullering. Reducing diameter enlist the sequence of operation required to produce hexagonal head bolt. Upsetting, edging, flattering, blocking, finishing, trimming.